This one is going to be 3y squared. This is with respect to x, and this is y. Since we wanted to solve for dy. Welcome in this video, and here is our next example on how to apply implicit differentiation to work out given functions. Just to remind you that in implicit differentiation, we apply it when we cannot be able to write the function in terms of y. Now, in this example, we have x squared or x cubed minus y squared is equals to 4xy plus y cubed. You notice that even if you can try to write the function in terms of y, not going to be very easy for you. And therefore, we are going to apply implicit differentiation to work out this. Now, for us to apply differentiation, we are going to find d dx on both sides of the function, d over dx of our function x cubed minus y squared should be equal to d dx on the right side of the equation 4xy plus y cubed. Now the next thing is to differentiate implicitly. So to differentiate implicitly, and as I told you, when you have d over dx over function y, this is going to be dy over dx, and this is our interest. That is the main interest, and therefore we're going to find the derivative of x cubed is 3x squared minus the derivative of y squared is 2y, but we multiply that by d over dx, that is going to be dy over dx is equals to, now this is a product, 4xy is a product, so to find its derivative, let's have 4 outside. We're going to take the first one, which is x, multiply by the derivative of the second one, which is going to be dy over dx. Then we add to the second y, multiply by the derivative of the first, which is simply 1. And we add to the derivative of this one is going to be 3y squared. But since it is with respect to x and this is y, then you're going to have dy over dx. Right, so we have to identify those terms that have dy over dx, dy over dx, dy over dx, since we wanted to solve for dy over dx. So first of all, let us simplify this here. So that we're going to have 3x squared minus 2y dy over dx is equals to, opening the bracket here, we have 4x dy over dx plus 4y plus, now this is going to be 3y squared dy over dx. So if we identify those terms that have dy, if we identify those terms with dy over dx and we have them on one side, and then we solve for dy over dx, then we use this room over here, that we are going to have the first term is negative 2y dy by dx. Now the second term is going to be minus 4x dy over dx, and the other term is going to be again minus dy minus, going to be minus 3y squared dy over dx is equals to those terms that do not have that is dy over dx are 3, 4. We have 4y minus 3x squared. 3x squared. So here we need to solve for dy over dx. Therefore, let us factor out dy over dx. So dy over dx is equals or multiplied by negative 2y minus 4x and minus 3y squared is equals to 4y minus 3x squared. And for us to do it very well, let us have the negative outside. So that's going to be negative dy over dx is equals to 2y minus 4x minus 3y squared is equals to 4y minus 3x squared. And now we can divide both sides. This multiplied by, we can divide both sides by 2y minus 4x minus 3y squared divided by 2y minus 4x minus 3y squared, and the value of dy over dx is going to be equal to, now this negative will make this a positive and this a minus, and therefore that's going to be 3x squared minus 4y, and we divide all this by 2y minus 4x minus 3y squared. That becomes the derivative of our function right here. It's very hard to derive that function using the product rule or the chain rule or the quotient rule or whichever method. But when you use implicit differentiation, then it's going to be very easy for you to work it out. Follow through and you're going to understand how it's done.